Good morning once again. So the last session for this day is session 14, which will be blockchain applications across domain. I welcome our guest speaker for this session, Dr. P. Tyagarajan. A warm welcome to you on behalf of the participants and the organizing committee, sir. So Dr. P. Tyagarajan did his integrated master's from
Mabel ma'am, your voice is not audible. Mabel ma'am.
He has delivered talks in various reputed colleges and universities in Tamil Nadu and Kerala. He is also member in board of studies for various universities and colleges across Tamil Nadu. He is a research proposal reviewer for National Science Center Poland. He is a reviewer for journals such as IEEE Signal Processing Letters, Computer and Electrical Engineering, Elsevier, 3D Researcher, Springer, and other journals. His research has been widely cited by researchers across countries, and so far now he has got 131 citations with H index 7 and I-10 index 3. We are so privileged to have you this morning with us, sir. Over to you.
Thank you so much. Nice introduction, ma'am. I hope my voice is audible and my screen is visible and my video also is in a good quality. Okay, good. So for the next 1 hour or so, we're going to discuss on blockchain applications across domains. So this is the agenda for the next 1 hour. Introduction to blockchain, issues with the current banking system, how Bitcoin solves
Sir,
this
one
issue.
second. Your screen is not shared. Can you
Not shared.
share your screen? Yes, sir.
Okay. Okay. 1 second.
Yeah, now it is visible.
No, 1 second.
Now it is
Just
visible.
1 second. Can you please wait for 1 second?
Yes, sir.
Is that okay now?
Yes, sir. Fine.
Okay. So this is the agenda for the next 1 hour. We're going to discuss introduction to blockchain, issues with the current banking system, and how Bitcoins helps us to solve the issues in the current traditional banking system, how the Bitcoin transaction works, details of Bitcoins, and how blockchains is also helpful in retail, in IoT, music, and electronic voting. And finally, we'll have the question and answer session. So what is blockchain? So you might have been discussing the same for the last 4 days, but it is a custom to introduce from my part also what is blockchain and then go for applications. So blockchain is a system which records information, either it's a transaction or any other information in supply chain or any other applications. So that makes it difficult or impossible. Once you put something in the blockchain, it is impossible to change or to hack or to cheat the system. So blockchain is essentially, we can call it as a digital ledger of transaction that is duplicated and distributed across the network of computers on the blockchain. So the ultimate aim of this blockchain is that it is decentralized and distributed. So whoever be part of the blockchain, he will have the entire ledger straight from starting of that particular blockchain till up to date transactions or details with respect to the application will be there. Total complete information string from inspection till date will be there in that blockchain. So every block in the chain contains a number of transactions, and every time a new transaction is being added, a new block will be added, and that will be visible to all the participants in the blockchain. So as I said, it is a decentralized management. managed by multiple participants. So as I said, it is decentralized and distributed. So since it is decentralized, it is managed by all the people who were involved in that blockchain, and it is also known as distributed ledger technology. So blockchain we can call in short as a DLT. It's like nothing but distributed ledger technology, in which transactions are recorded with an immutable cryptographic signature called hash. So these are some of the properties of the distributed ledger technology. When it is programmable, the blockchain is programmable with the help of the smart contract, and it is very secure. All the records in the blockchains are encrypted, and third feature is anonymous. The identity of the participant is either anonymous or pseudo-anonymous. We can have a completely anonymous, or if I want to have pseudo-anonymous, that is also possible. And it is distributed, it is immutable, it is time-stamped, and it is unanimous. So timestamp, every transaction in the blockchain will have a timestamp attached to it, by which you can easily identify which transaction will take place at what time, and it also helps us in terms of the security also. So the growth of the blockchain, if you see, by 2023, the blockchain will support the global movement and tracking with 2 trillions of goods and services annually. So this is what the status given by the Gartner. And on the right-hand side of the PPT, you can see how the blockchain has evolved from where to which state. So the average number of monthly initial coin operation, you know, IPO in stock, right? Initial public offering. Similarly, like IPO, we have ICO, that is initial coin offering. So it has went from 8 to 200, and this investment on this ICO initial coin offering is increased to 16 times. So these are some of the statistics which shows how the Bitcoin is growing or the blockchain is growing in leap and bounds, and it emphasizes its growth actually. It portrays the growth, and it says that $2.1 billion throughout the global they are spending on this blockchain solutions. Excuse me. And $20 billion around the global market is expected to be investment, the investment in the blockchain by 2024. And the bankers are expecting this commercial blockchain adaptation probably by next year. And Ethereum grows 50 times. And now 14 countries exploring the developing official cryptocurrencies. And the LinkedIn profile are also being provided in the blockchain. So that has been increased in 3 times. And the bank currently experimenting with the blockchain technology. 69% of the banks around the world is experimenting on this blockchain technology in various domains of it. And if you see, $8 to $12 million potential annual saving for the bank if they utilize banking technology. That is a very important point to be noted here. If we use this blockchain technology, it saves from $8 to $12 billion for the banking sector, which is very noteworthy point. Apart from offering so much of features like security, decentralized and distributed, blockchain also helps us to reduce the cost of the banks if they adopt this technology. So this is how the blockchain transaction take place. Maybe with the respect, I have given a lecture here. So it contains the account number, it contains the number of amount of rupees that has been transacted with that particular moment. So every time the transaction take place, that needs to be updated in this ledger. So every transaction holds the detail of the currency which is being transferred from the one account to the another account. And here the balance, it means that it should be actually the amount which is being transferred from one account to the another account. And next we have the balance of any account is calculated only by calculating all the transactions, not by looking at the ledger. So each time when you have a transaction, so each and every block will have many number of transactions. A block, okay, these are called blocks, and new blocks is being added, and each blocks will have many number of transactions which is taking place in a particular period of time. Once the block size is completed, then the next new blocks will be created, and again it will contain a number of transactions within it. This is how the blockchain flow diagram works. I'm talking with respect in general term. This is a flow diagram in general term. So someone requests a transaction. So the transaction will be broadcasted to the peer-to-peer network. We all know what is a peer-to-peer network. So there will not be any centralized one to manage the system which is there on the network. They will be managing it themselves. And these transactions will be passed to the peer-to-peer network. And once it has been passed to the peer-to-peer network, the nodes within the network want to validate the transactions. Because as I said, they are distributed and decentralized. Each and every parties in the network, here there are 4 parties. The 4 parties in the network will have the ledger in it. Okay, so with the help of the ledger, each and every node in the network will be able to validate whether the transaction is valid or not. Valid in the sense, suppose A want to transfer some amount to B, and it will check whether the A has a sufficient balance. So that is called a validation. So only unless otherwise you have a balance, you cannot able to transfer to a counterpart. So those kind of validation will be verified by all the people in the network. Because each and every people who being part of this network are responsible for validating the transactions. So that will be done in the 3rd step. So once all the people in the network can able to validate, how they can able to validate, because each and every people will have a ledger. The ledger will contain all the details of the transaction from the inspection to till date. So with the help of the ledger, people in the network, nodes, we call it as nodes, will validate the transaction. And once the transaction are verified, it will add to the blockchain. And finally, it will say that the transaction is being completed. This is the top level overview of the blockchain workflows. So the blockchain is a technology used in the Bitcoin. Bitcoin, it's very popular cryptocurrency. So blockchain is a technology which is behind the Bitcoins, and it's a public distributed database holding the encrypted ledgers. So as I said, we have a ledgers, and the ledgers are always encrypted. So a block we can define like this. A block is a current part of the blockchain which records some or all of the recent transactions, and once completed, goes into the blockchain as a permanent database, and each time a blocks get completed, a new block is generated. So what is a block in blockchain? We can say it is a current part of the blockchain which records some of all of the recent transactions. You can either have few transactions with it, not one, definitely not one. It will have few transactions in it, and once the transaction is being verified, it will just keep on adding into the blockchain. So these are the 3 important technologies with behind this blockchain: private key cryptography, peer-to-peer network, and the blockchain program. These cryptography, of course, it's it's a backbone of this blockchain, peer-to-peer network, and the blockchain program. So these 3 things put together jointly build this blockchain technology. So what is private key technology, and in this private key cryptography, you will use hash functions also, which makes the blockchain immutable. Immutable in the sense, anything if you put it in the blockchain, it cannot be changed. That is called immutable. And peer-to-peer network, peer-to-peer machines on the network helps in maintaining the consistency and the distributed ledger. So whenever we have a distributed environment, the main ultimate problem is that consistency of the data. Okay, consistent in the means, what I'm trying to say, the data which is being distributed all should be correct enough. All the data should be of same. If I want to know the transaction details, I should not get 2 answers for a transaction details. Only one unique output should be for the transaction details. The data which is being there in the distributed ledger has to be very unique. So it cannot be variated in node A, and node B cannot give a various answer for the same one which is being provided by the A. Any point of time, all the records in the ledgers which is being distributed should be the same. To maintain the consistency, this peer-to-peer network helps us a lot. Third, the program gives this blockchain technology and protocol. It is based on the requirement. So these are the 3 main building blocks which is behind the blockchain. You all know what is peer-to-peer digital signature. Digital signature concepts, the same has been portrayed here. So whenever you have the signer, so we have a data here. So the signer is data is that here. So we will find the hash function of the data, and the hash function is being encrypted using the private key cryptography. And at the end, we'll have the data as well as the hash thing, a hash which is being attached to the data. And this is being, of course, this data is also being encrypted. This is being transmitted. So after being transmitted, the receiver or the verifier end will have we'll have this data as well as the hash value. So here, if you will take this data and you will find this hash value, and again this digitally signed one will also take this and will decrypt, and we'll check whether both these hashes are matched. Once both these hashes are matched, then we will say that there is not an error in the transaction. So this is digital signature, and the verifier will also verify it by using the hash value comparison between the data and the hash value. So for the last 4 days you have been going extensively on the blockchain. So with the help of the knowledge you gained on the blockchain, can you able to map the figures which is given there in the form of a sentence? So there are some 7 figures which is being portrayed in front of you. So I want the participant to form a sentence regarding the blockchain with the help of the figures which is projected in front of you. So being the last session, I know you'll be tried enough. So I thought I should have some this kind of fish so that you'll all be active. So can you able to form a sentence with help of this figures which is portrayed in front of you regarding the blockchain? It's like maybe you can map to the connection game. So these are the figures. With the help of these figures, can you able to form a sentence with respect to the blockchain? Okay. I will just say, so this is the use of, this is mathematics, the use of mathematics for the secure ledger in peer-to-peer network transaction. This is without third party. So if you form a sentence with respect to this is the sentence: the use of mathematics to create the secure distributed ledger which enables transaction without the need of third party. This is what we can able to say with respect to the figures. We can able to form a sentence like this: the use of mathematics to create secure distributed ledger, okay, in peer-to-peer network which enable transactions without the need of third party. So here I have a video for the blockchain in 2 minutes. We'll just have a look on it.
When you vote, have you
Whether the video and audio is visible, madam?
ever wondered whether your ballot is actually counted?
Yes, sir.
If you
Yes,
meet
sir.
someone online, how do you know they're who they say they are? When you buy coffee that's labeled fair trade, what makes you so certain of its origin? To be sure, really sure, about any of those questions, you'd need a system where records could be stored, facts could be verified by anyone, and security is guaranteed. That way, no one could cheat the system by editing records, because everyone using the system would be watching. Systems like this are on the horizon, and the software that powers them is called a blockchain. Blockchains store information across a network of personal computers, making them not just decentralized, but distributed. This means no central company or person owns the system, yet everyone can use it and help run it. This is important because it means it's difficult for any one person to take down the network or corrupt it. The people who run the system use their computer to hold bundles of records submitted by others, known as blocks, in a chronological chain. The blockchain uses a form of math called cryptography to ensure that records can't be counterfeited or changed by anyone else. You've probably heard of the blockchain's first killer app, a form of digital cash called Bitcoin that you can send to anyone, even a complete stranger. Bitcoin is different from credit cards, PayPal, or other ways to send money because there isn't a bank or financial middleman involved. Instead, people from all over the world help move the digital money by validating others' Bitcoin transactions with their personal computers, earning a small fee in the process. Bitcoin uses the blockchain by tracking records of ownership over this digital cash, so only one person can be the owner at a time and the cash can't be spent twice, like counterfeit money in the physical world can. But Bitcoin is just the beginning for blockchains. In the future, blockchains that manage and verify online data could enable us to launch companies that are entirely run by algorithms, making self-driving cars safer, help us protect our online identities, and even track the billions of devices on the Internet of Things. These innovations will change our lives forever, and it's all just beginning. To learn more,
I hope that video summarizes in 2 minutes what is a blockchain and a few applications regarding it. So now we're going to discuss on the introduction, and now we're going to discuss on what are the various applications in which we can apply this blockchain. And there are n number of applications, but then I have taken here some 7 applications, and we're going to discuss that. It can be applied extensively in banking, property governance, Internet of Things, food chain, healthcare, electronic voting, and music world. Music in the sense audio. Okay, so how we'll see extensively how we can use this blockchain on these 7 different domains. First, we'll take this banking application. So before we going to discuss an application of this blockchain in banking domain, we should first discuss what are the issues that the current prevailing banking system has. So the first issue with respect to the banking system is nothing but a high transaction fee. So have you ever thought that whenever we want to transfer a money from our money to our friends or to our parents, we are charged the transaction fee? Maybe it may be 2 rupees or 10 rupees according to the banks. But have you ever thought why we should pay this transaction fee? Because it is our hard-earned money and we are transferring our hard-earned money to someone else. And why we should pay, even if it is 2 or if it is rupees 10, why we have to pay this transaction fee? So that is an issue with the current banking system. For example, here I have taken Chandler and Joy, and here Chandler wants to transfer $100 to his friend Joy, and definitely this transfer has to take place with the help of the bank, and in between there is a bank which has the transaction fee light, so he will have the transaction fee of $2. So this is very pathetic condition because we have to transfer our money, but then someone who is sitting as a facilitator, we have to pay some amount of money for them. So this is bothering. So for us, if it is a single person, it is only $2. Imagine that per day, how many transactions will take place throughout the world, and each of the transaction will having a transaction fee. Imagine how much of revenue the third person who is there in between the recipient and the giver, how much of money he will be generating per day. So that's a big question mark. So some of the statistics which says that the JP Morgan Chase, Bank of America, and Wells Fargo earned $6 billion only with from ATM and the transaction fee. So that is what the statistics in 2015. Now in 2020, it will be even more because now more people are moving towards the digital transactions. So now the revenue which is being generated out of this transaction would be much more just by being the middle, who doesn't involve. They are just gaining a much amount of money with luxury. That is what a bothering thing. So our hard-earned money being paid to some third party who is there in between, who is a facilitator for us to enable this thing, they are earning in millions. So this is a issue in the current banking system. So transaction fee for doing the transaction, it's bothering us. The second issue with the current banking system is nothing but the double spending. So imagine that Peter wants to transfer his money to Alison job, but then the Peter balance is only $500. Imagine. So at the same time, same instance, Peter can able to same instance he can do 400 to Alice and 500 to Bob. At the same time, same instance, this can be happening in a traditional banking system. So that is an issue called double spending. So the ultimate balance is 500, but then the Peter is trying to do the same transaction at the same time by forging the digital signature. You want to do that 400 and 500. You want to say it to Alice and Bob, but the balance is 500, but the transaction, if you see, it is 900. This is possible in this current online prevailing bank. Okay, prevailing situation, it is possible. The double spending is possible. So bank transaction digital are prone to double spending, which is again a threat. The third issue with this banking system is that banks become synonymous with the crisis and crisis due to depression and fractional reserve banking. You know, many of the banks in US are being shown they have been crashed due to their economic condition. This is one of the third reasons with this prevailing in the current banking system. So we have seen some of the issues with the prevailing banking system. For all these pitfalls or all these shortcomings in the existing banking system, we have a solution called Bitcoin. We're going to discuss in detail how Bitcoins is going to address all of these issues which is being discussed here. So the Bitcoin is the white paper which is being launched by Satoshi Nakamoto on 31st October 2008. It is Halloween Day in US. So this Satoshi Nakamoto is a pseudonym. The original name is not being reflected. It is a pseudonym actually. So this is a white paper which is being released in 2008 on the Bitcoin. So this Satoshi Nakamoto created a reference implementation of this Genesis block with only 50 bitcoins. So in 2008, August 18, the domain name bitcoin.org was registered. So any business now, before they are even starting that, we have to register the domain name. Otherwise, it will be very difficult. If we start the business, then we go in for registration of domain name, then someone would have been created and will not be able to get the exact domain name. So here, cleverly, the Satoshi Nakamoto registered the domain name in August 18. In August 31, he published the paper. And in November 9, the Bitcoin project was launched in SourceForge.net. The SourceForge.net will contain the source code of many of the open source programs. So this blockchain Bitcoin's code also has been registered in the SourceForge.net. In 2009, if you see in January 3, the Genesis block was created and established at 1815. And in January 9, the Bitcoin version 1 is being released and it is announced on the cryptography mail list. And in January 12, the first Bitcoin transaction in block 170 from Satoshi to Halfin has been taken place. These are some of the history of how the blockchain has been evolved. So what is a Bitcoin? Sorry, Bitcoin is nothing but a protocol that supports decentralized, pseudo-anonymous, and peer-to-peer digital currency. A publicly disclosed linked ledger of transactions stored in the blockchain. And Bitcoin is also a reward-driven system for achieving consensus based on proof of work for helping the secure network. We are going to discuss extensively on each of the words which is being highlighted here in the forthcoming slides. We're going to discuss proof of work. So this proof of work is necessary for ensure the security in these Bitcoins, which prevents the fraud and can enable trust among the peoples who are in the Bitcoin transaction. So the proof of work is difficult, costly, and time consuming to create, but it is easy to verify. So I can give an example to map this proof of work concept. So if you want to have an example, like you know the number lock, right? So the number lock can be easily mapped to this proof of work. So in the number lock, if the number lock has been locked, imagine that you have a number lock with a 6-digit in it, and it is locked. And if we ask to find a solution for this lock, of course, it will take 6 factorial times. The number of, you have to try by brute force attack. The number lock is locked and you are been assigned a task to release the lock. So what you will do is that you will try every possible combination and you make sure that the lock is being released. So it is nothing but brute force attack. So that's the only possible solution. If you give a number lock being locked and if you want to unlock it, you have to try every possible solution. So it is possible to find a solution to open the lock. It is possible, but it will take much time. But there is the only way also. We cannot have another way to unlock it. And if you forgot the number lock, a number for the number lock, you have to do all possible combinations to unlock this lock. Here, if you see this proof of work, to find out the solution here, you can see, you can map this proof of work, you can map this simultaneously for the number lock. To find a solution for the number lock to unlock, this being very difficult. That is what proof of work. The proof of work is difficult, costly, and time consuming to create. But if you find a solution for the number lock, it is easy to verify. Why it is easy to verify? Because if you put the number lock correctly, the number, hello?
I'm in meeting. Unless Sunday work and then update me progress.
Can participants can please mute their mic, please?
Maybe in the evening call. I'm in meeting now. Huh?
Hello. May I request the participants to mute the mic, please?
Muted, sir. You can
Thank
go
you.
ahead.
Thank you so much. So this proof of work can be mapped to a number lock. The finding a number for the number lock to unlock is very difficult, but then to verify the number found out to unlock the number lock is very easy. That is what proof of work. So that's why I said it is very difficult, costly, and time consuming to create. Here the time consuming to find the number in the number lock is very difficult, but once you found out the number, it is easy to verify, because just you put the number in the number lock which is found out. If the lock is unlocked, then you go ahead, you can proceed further. The same thing can be referred to as proof of work. So Bitcoin is secure because it is computationally infeasible to attack the network, and requiring this proof of work for participation is central to the property. Hence, Bitcoin relies on the computational work on cryptographic challenges as a basis of trust. As I said, private key cryptography also plays a very important role in Bitcoins. You all know what is private key cryptography. I'll just skip the slide. Then we have P2P network. So imagine that peer-to-peer network, you have this following peer-to-peer network, and you have communicating parties like A, B, and C, and you want the Bobby want to transfer $5 to Cindy. Imagine that this is what the case. Okay, so now what the A will do? The A will broadcast to the peers B and C in the network, and that is Bobby is going to transfer some amount of money to Cindy. And all the participating node, the node which is being highlighted are the participating node. Now A, B, C are the participating node, and now Bobby want to transfer $5 to Cindy. That is what the situation. So since A, B, and C are the only participating node in this transaction, only those are highlighted. And since it is a distributed and decentralized, now A will try to broadcast that B is going to transfer $5 to Cindy. B means Bobby. Bobby is going to transfer $5 to Cindy. So this is being broadcasted to all the active nodes in this transaction. So each and every node will now receive the message, and each node in the participating transaction will verify whether the transaction is valid or not. Okay. Once all the node is being verified that the transaction is valid, then they will accept the transaction. Okay. If the transaction is verified, then the peers forward the transaction to other nodes on the network. So this way the transaction propagate rapidly across the network. So once the transaction is being verified by each of the nodes which is there in the transaction, then the transaction will be forwarding to the another nodes which are connected. See here again, this is a pictorial representation of the same which I discussed here. So here we don't have any centralized ledger. So that's why I given a cross mark, and there is a ledger with all the people who is there and that's involved in this transaction. See here, each and every Andy, Bobby, Cindy, and Debbie, each one of them having the ledger. Okay, there is no any centralized body to control. It is decentralized and distributed. So initially, you see these bitcoins use cryptography to control its creation and its management. And initially, when the cryptography was originated in 2009 somewhere, it was under the stage that only 21 million bitcoins can be created. Okay, but this Bitcoin group is being constantly working on a cryptography algorithm and the mathematics involved in it. The Bitcoin group makes sure that these bitcoins will be exhausted only by 2140. Sorry, not 2140, 2140. So now they have increased this number of bitcoins, and by 2140th year, this bitcoin will be terminated. Terminated in the sense will be exhausted. So what is a ledger? You may ask a question. So ledger is nothing but a series of blocks of the blockchain, which is being produced using the software that involves this mathematical problem. So we will see what is a Bitcoin here in a short video.
Sir, the audio is not
Yes, ma'am.
there.
Audio?
Audio is not played.
What is not played? System audio was included, ma'am, actually.
Okay, sir, but the audio is not played.
1 second.
Okay.
Wait, I will share it 1 second.
Yes.
Is it okay?
Bitcoin
Is it okay? Can you able to hear the audio?
the
Yes, sir.
first
Yes, sir.
decentralized digital
Madam Dhalakshmi? Hello.
Sir, the audio is okay.
Now it's okay?
Yes, sir. Play it now.
Bitcoin. Bitcoin
Yeah,
is the
the audio
first
is there.
decentralized digital currency. Bitcoins are digital coins you can send through the internet. Compared to other alternatives, Bitcoins have a number of advantages. Bitcoins are transferred directly from person to person via the net, without going through a bank or clearinghouse. This means that the fees are much lower. You can use them in every country. Your account cannot be frozen, and there are no prerequisites or arbitrary limits. Let's look at how it works. Several currency exchanges exist where you can buy and sell Bitcoins for dollars, euros, and more. Your Bitcoins are kept in your digital wallet on your computer or mobile device. Sending Bitcoins is as simple as sending an email, and you can purchase anything with Bitcoin. The Bitcoin network is secured by individuals called miners. Miners are rewarded newly generated Bitcoins for verifying transactions. After transactions are verified, they are recorded in a transparent public ledger. Bitcoin opens up a whole new platform for innovation. The software is completely open source and anyone can review the code. Bitcoin is changing finance the same way the web changed publishing. When everyone has access to a global market, great ideas flourish. Bitcoins are a great way for businesses to minimize transaction fees. It doesn't cost anything to start accepting them, and it's easy to set up. There are no chargebacks, and you'll get additional business from the Bitcoin economy.
So there's a short video of the Bitcoin, and we have discussed the things which is discussed in the video and the previous slides. So now, why there is so much hype about the Bitcoin? Why it is being talked all over the world, and why it is being implemented as a part of the digital currency in many countries? So if you want to know the value of one Bitcoin in INR, it is about 7,87,837 rupees and 32 paise. As on today, this is value of Bitcoins in Indian rupees. And below is a graph which portrays how the value of the Bitcoins varies across 6 months from June 2020 to September 25th. I have drawn a graph. If you see, the x-axis is all about the time period, and y-axis nothing but the price of the Bitcoin, which is being changing in all the 6 months. If you can see, it has been the value of the Bitcoin also varied, and it has been touched around 9.25 lakhs. Around mid of August, value of one Bitcoin was 9 lakhs and 25,000 rupees. So now it is 7,87,000. So it varies. Bitcoin also fluctuates and also varies. So there is so much hype over the Bitcoins only because of its worthiness and the technology which is it is built. So we have discussed the certain issues with the current banking system, and now we're going to see whether these Bitcoins addressed all of the issues which is there in the traditional banking system. So what are the issues we have seen in the traditional banking system? We have seen that traditional banking system is always centralized. Okay, so each and every bank will have a centralized office. So all of the branches will be connected to the central office. So only we have a complete control in the central office. So every bank in the traditional banking system is centralized. So this is one issue, the prevailing banking system, that is centralized part. Second, the ledgers are very private. Ledgers in the sense, each and every customers will have a separate file in which all the transaction details will be stored, and it is very private. It is not public for common people, and you cannot view, other persons cannot able to view and poke their nose into the ledgers of individuals. Again, that is called an issue with the private banking system. And the third one is nothing but it can prone to attack. So imagine that the centralized database in the central office is being compromised by the hackers, then all the data will be taken by the hackers for their use. So all these centralized things can prone to attack. And the fourth one, we are talking about double spending, which have discussed in the few slides ago. That is also an issue with the traditional banking system. So now we'll see how Bitcoins have solved all of these issues. You all know the Bitcoins works on this blockchain, so which is nothing but decentralized. So now Bitcoins solve this issue in the traditional banking system from centralized. It has been evolved to decentralized as it has the ledger distributed. And we have made this ledger which is public in the traditional banking system. Now we have made the ledger public to all. So ledger is public to all the people who have been involved in this transaction. Third, the centralized system in the traditional banking system can prone to attack, but the transaction in this bitcoins are immutable and it is very difficult to hack. Fourth, we have eradicated this double spending, and the Bitcoin structure will not allow any of the double spending which has been discussed. So with these 4 features, Bitcoins are being addressed the issues which is prevailing in the current traditional banking system. And the best part is that you need not pay any transaction fee. If you want to do any transaction in the Bitcoin, it is 0 transaction fee. And there are now few Bitcoin systems which platforms which charge very, very minimal transaction fee. Most of the times the transaction fee is 0, but now they are charging very, very little compared to the traditional banking system transaction fee. This transaction fee are very, very negligible. As I said, blockchain is the technology behind the Bitcoin. So here in this slide, I'm going to say how I'm going to discuss how this Bitcoin transaction take place. Imagine there are 7 people, Kevin, Paul, Robert, Lisa, James, Stephen, and Rahul. And here the James want to transfer some amount to Kevin. So let us say the Bitcoin transaction where James want to transfer the 500 Bitcoins to Kevin. So the transaction is a part of a new, okay, see here, there are out of the 7 participants, the 2 participants are designated as minus. So can you able to see that? Robert and Lisa are designated as minus. So the minus job is to verify the transaction. So whatever transaction is being taken place, this miner will verify whether the transaction is valid or not. So for this, they need this proof of work. Already I said that the proof of work is, the proof of work solution construction is very, very difficult, but verifying is always easy. So you can map this proof of work to the number lock. Okay, that's why I said. So these miners will work on this proof of work. So as I said, it involves a lot of computational facility. So if you want to verify if you want to verify a transaction in the Bitcoin, it is not an easy task. To verify a transaction in the Bitcoin, you need lot of computational facility. You cannot be solved by having only one high-end system. You need to have a big server with high computing capacity, and all of the servers has to be connected. Only then you can able to solve this Bitcoin. Only then you can able to verify the Bitcoin transaction. So since this Bitcoin verification involves this many of computational cost, a single person cannot afford to buy these computational cost machines. So what they will do, they will form a group and they will invest to buy this many costly power servers, and they will form a group. So they are called miners. The miners is the person who actually verifies the transaction. Okay, so someone has to verify the transaction, right? So the miners will always verify the transaction. As a amount, since someone is not going to verify the transaction which is very high computational cost. So these miners are the one who's going to verify the transaction with the infrastructure of computation facility which is available in their lab. Imagine someone is going to verify, it involves high computation cost. We need to reward them, right? Some of this Bitcoin has to be generated. So as a reward, as a token of appreciation for verifying the transaction, these Bitcoins will be awarded to the miners. That is the only source where these Bitcoins will be generated. So miners will always be awarded with these Bitcoins once they verify the transaction. So here, James want to transfer some amount of money, 500 Bitcoins to Kevin. That is what the ultimate purpose. So the transaction is a part of a new block that is being validated by the miners Lisa and Robert. The Lisa and Robert are the miners who will be designated as miners, and they will verify the transaction. So as I said here, for the whole of the things, so James is giving 500 Bitcoins to Kevin. This transaction will be completed in 10 minutes, but to verify the transaction, whether James can transfer money to Kevin, whether he has sufficient balance, that confirmation part will take 30 minutes. Because as I said, it involves proof of work, which is high computation cost, and time also it will be taking much time to verify a transaction. So verifying the transaction will take 30 minutes, but for completing the transaction will take only 10 minutes. So this is how the Bitcoin transaction take place. These are some of the features of Bitcoin. Yeah.
Sir, all the participants need not mine the data?
No, sir. All the participants will not mine the data. Why? Because the mining data is not very easy. It involves a high number of computation and infrastructure facility. So all participants will not be able to do that, sir.
Sir, and one more question is, now also for the miners, we have to pay some bitcoins. In the traditional setup for the bank, we will be paying. Here, what is the difference, sir?
Sir, bank, see, what here I'm trying to say is that, see, now traditional banking system, we have the private ledgers. Now the ledgers are common to all the people who are being involved in this transactions. Okay. But someone is making a transaction, we want to verify the transaction, right? For verifying the transaction, it needs a lot amount of computation facility. So these computation facility cannot be afforded by a single person. So a group of persons will invest on this infrastructure and they will be designated as a miners. These miners are those who will verify the transaction taking place. Okay, as I said, it will take much amount of time. So for the proof of work, I have given a sample example also, right? Locking, releasing a lock from a lock which is numbered. So that much amount, if it is a 6-digit, you can try maybe possibly by half a day, you can able to find a number which unlocks a lock. But in general, that's a very simple problem I can map to this proof of work. But general, that problem is not very simple. To find that number, to find that, to verify this transaction, that amount of proof of work has to be done. So for that, we need huge number of computation facility. So in order to reward for the person who is doing this mining job, see, imagine why a person should mine then. Why a person has to spend so much of time and wants to invert so much of infrastructure only to verify a transaction. Somehow we have to reward, right? So those who are succeeding in verifying the transaction, we will award a Bitcoin. That is the source of generation of Bitcoins. We will award Bitcoins to them. Then that Bitcoins will be in circulation. In traditional banking system, RBI will print this currency, right? Based on the economic formula, RBI will bid the RBI will release the currency, release the new currency. But here, Bitcoin miners, we will reward the Bitcoin. That's the one way by which you can generate or give the Bitcoins to the circulations. Hello, I hope I answered the question.
Fine, sir. Yes, sir. Yes, sir. Fine, sir.
Okay. These are some of the features of Bitcoins. Essentially, it is de-inflationary. If you see in the beginning, the reward which is given for the miners is very high. But if you see now, every 4 years, the rewards has been decreasing. So it is deflationary. And Bitcoin transaction, you can also transact 0.001 Bitcoin. So it can vary up to 8 decimals. So Bitcoin transaction take place in decimals also. So generally, there will not be any transaction fee involved. But now slowly they started to give some transaction fee charges. So it is concession driven. So there is no central authority. And you cannot add coins arbitrarily, or you cannot do any changes in the ledger, as it is strongly behind the cryptography. And double spending is being avoided, and non-reputation is being maintained in the Bitcoins. These are some of the features of Bitcoins. So the blockchain refers as the highest in terms of security. So the Bitcoins, and these are things which I have discussed. The second application, so first application we have discussed, it's on blockchain, Bitcoins on banking domain. Second, we're going to discuss on property governance, how these Bitcoins can help in the property governance. So I'm running short of time, so we'll just quickly scan through. So these Bitcoins can also be applied on this property governance. So I will just play this video due to short of time, and then we will discuss now and then. I think the system audio is being stopped now and then automatically. Please bear with me. I will work on that.
Real estate is incredibly
Can you able to see the video and audio is clear?
complicated. Ask anyone who's ever bought land or a home. It's time-consuming, complex, risky, and above all else, it's expensive. Home inspectors, real estate agents, banks, local governments, everyone needs to check and sign off on your transaction before it can get done, and all of them take a cut.
In the last part of our series, we're going to quickly outline how blockchain technology can make the process of buying and selling real estate much, much easier. When buying real estate, the rules can be daunting. They vary wildly depending on what city, state, or country you're looking to buy in, what type of property you're hoping to buy, and how you're going to buy it. All of these complexities and regulations require multiple middlemen to get involved. You're going to be paying a large cut at every turn because it's just too complex for most people to navigate alone. That's where the blockchain comes in. If we were to codify local, provincial, and national housing rules and regulations on the blockchain, smart contracts could be used to drastically simplify the process. A prospective seller would simply send their location, desired price, and some other ownership information to the contract. Then, pulling from the database of rules and regulations around the sale of real estate in the seller's location, the smart contract could generate contracts, deeds, tax records, anything required to make a sale of the house instantly. A prospective buyer could then meet with the seller, agree on pricing and terms, and then send their digital signature to the contract, verifying their purchase and updating all the documents as required. Now, this would require some back-end work having provable and verifiable identities on the blockchain to ensure that the transactors are who they say they are, and there can be no disputes with regards to signing. Similarly, the land would need to be securely and clearly registered on the blockchain to ensure easy transfer of ownership. We'll delve a little bit into that here, but we have an excellent workshop over on blockgeeks.com that talks more about identity management and real estate on the blockchain. You should check them out. India has looked into blockchain as a possible solution to complicated land registry problems, as they have many issues with property fraud. In 2013, New Delhi alone had 181 reported cases of property fraud, while Mumbai came a close second at 173 cases. To counter this issue, the governments of Andhra Pradesh and Telangana have partnered up with Swedish startup Chromaway to put their land registry on the blockchain. One of the many interesting innovations they could be bringing is the introduction of cryptographically secure digital fingerprints. It might work like this. A landowner hashes the geo-coordinates of their land, along with the description. This hash is then tied to the owner's ID, and the result is hashed again and added to the blockchain. Since hashes are always a unique value, every plot of land tied to the owner's ID coordinates of their land. It might work like this.
So this video is all about how we can use this blockchain on this properties. So this has been adopted, and already process has been started in Telangana and Maharashtra to implement this blockchain on this sale deeds as well as purchase and registration of lands. So please watch this video.
A landowner hashes the geo-coordinates of their land, along with the...
So you know the geo-coordinates, right? Nowadays, if you take a photo, you can also enable the geo-coordinates, which is say the latitude and longitude when you take the photo. Suppose if I take the photo from CUTN, exactly it will say which latitude and which longitude it has been located. So it will also display, while taking the photo, in the photo you can have this longitude and latitude also. So if you're going for NAC nowadays always recommends a geo-tagged photo. Geo-tagged photo means your exact location also will be there in the photo. That is what he is saying. So what he will do, the property, you will take a photo and the geo-tagged information. Geo-tagged means exactly which latitude and which longitude it is available in the map. That has to be given. So that has to be given and it has been hashed.
Description. This hash is then tied to the owner's ID, and the result is hashed again and added to the blockchain. Since hashes are always a unique value, every plot of land and landowner will have a unique ID when linked together. Plus, because of the blockchain's immutability, no one can tamper with the records. This would create a system of verifiably owned land that could easily be transferred, bought, and sold in a cryptographically secure manner. Thanks for watching this series on real-world applications of blockchains.
So you might have seen the video. So how they have taken the information of an user information, geo-tagged information of the property, and they are putting the hash on it, and they have been putting in the blockchain. So as I said, any records in the blockchain which cannot be tampered, so no one will able to modify it. So this fraud in the land registration and all will not happen, because as I said, everything in the blockchain, everything will be with tagged information, geo-tagged information, the personal information together will be hashed and will put it in the blockchain, and no one will able to tamper any data in the blockchain. So records once put in the blockchain, it's complete and cannot be hacked by the hacker. So that forgery of the properties will not happen. Forgery registration of the property will not happen if you introduce this blockchain, this smart property. Already realizing this importance of the blockchain, Telangana government has started implementing this blockchain in the revenue department. So next, we're going to see Internet of Things. So now slowly we have been going to Internet of Things. Gone are the days where we have lack of data for our research. Now we have things can talk to things with the help of this IoT. Now we have surplus of data. Only problem is that how we are going to work on the data is the only problem here, not about the data. Now we have abundant data, but to get meaningful insights of the data, it's only a big thing. In IoT, one of the big major security is nothing but the security, because there are a lot of millions of devices are being generating the data and millions of devices are interacting. Our only concern is that whether the data is very authentic. Okay, whether the data is only from the particular device or not. That is what the big problem, and that is what the big question in the IoT. So with the billions of devices are linked to the cybersecurity experts worry how to make sure this distributed information stays secure. That's a big questions behind this security experts, and that's a big issue bothering this IoT industry. So we can also use this blockchain in IoT use cases. This is a diagram which shows how we can use this blockchain in this IoT. So imagine that we have IoT devices, smart car, smart watch, smart home, smart tab. So data is collected by this IoT hardware in technology enabled environment with the full powering machine. So all of these are technology enabled environment, and data has been generated continuously by these all smart devices. So once data has been generated, this data will be asserted and originated hardware is recorded. This data, so along with the data, we will also make sure that we will have information about from where the data has been generated. If it is from the smartwatch, we will have an ID in the smartwatch, and along with the data, we will also tag from where this data is being generated. Once this data has been generated, these data will be stored in the blockchain. So once the data has been generated and it is passed through the gateway, we make sure that the data will be stored in the blockchain. And we all know that data in the blockchain is immutable. So IoT data and business intelligence can be verified, traced, and trusted by everyone in the network. So if we introduce this blockchain in IoT, then we need not bother about the origin of the data, and we can really work on this data confirming the originality, and we have many fruitful results can be generated. So authenticity of the data can be also easily verified with the help of this IoT, properly deployed in the IoT. Next, we have a food chain. It's a very interesting application here in the food chain. So according to the 2008 study by United States, FMI, the Food Marketing Institute, they made a survey and they have realized that the public demand more in transparency with respect to the food market. So the customers are being nowadays, they are very health conscious, and they want to know the possible information about the food they have. So they want to know from where this food has been cultivated, when it has been harvested, when it has been brought to the store. So they want to know complete information about the food in which they are taking. So the specific report says that 75% of the consumer are likely to switch over the market, which is giving the complete information about the food which is offered by the particular company. If someone is offering the food product with no history, they are not preferring. They are always preferring a company which is offering complete details about the food they are consuming. Complete information means this one: when they cultivated, when they harvest, when they transported. So once a company is trying to give this kind of information, then the user is willing to only take food from that company which is giving the complete information. This is a very interesting application. So again, blockchain can also be an application on this food industry. I will explain that through one video. Very interesting application this.
It's not hard to say that
I hope you can able to hear my audio right.
blockchain technology is one of the biggest innovations of this century. Whenever we think of it, we automatically associate it with cryptocurrencies, primarily Bitcoin. However, that notion is starting to change rapidly. More and more people are seeing that decentralization and transparency have the potential to shake multiple industries to the core. So let's get right to it. In this video, we're going to explore the first of 4 real-world use cases of blockchain technology. First up, the food industry. Probably not the first thing that comes to mind when you think of blockchain applications, is it? But the fact is that many big shopping chains like Walmart are teaming up with IBM to incorporate blockchain in their food management system. But why would they be doing this? What if we were to make each and every step of the process, from the time the food grows on the farm to the time it reaches the marketplace, transparent? What happens if the blockchain gets implemented to maintain food records? Remember that the blockchain is an open ledger and the data in it is open to everyone, so there's no central authority taking charge of the records. This means that it would be possible for consumers to track the origin of all the food they purchase. From the moment your salmon was brought to shore to when it was laid out on the counter in front of you, you could trace where it was caught, when it was transported, and how long it's been in the store. That would be pretty amazing. Walmart has already done 2 test runs with IBM. one with pork and the other with mangoes. They used Hyperledger Fabric, a blockchain originally built by IBM and now housed under the Linux Foundation's Hyperledger group. If you want to learn more about Hyperledger, you should definitely check out our introduction. We even have complete Hyperledger training over on blockgeeks.com. Anyway, let's get back to the food. Frank Yanis, Vice President of Food Safety at Walmart, had this to say about the results of the trials, as told to Fortune. We were so encouraged that we really quickly started reaching out to other suppliers and retailers. As the blockchain gets integrated into the food industry, it will make the whole process more safe. There are many advantages to a transparent blockchain-based food system, the largest of which is being greater accountability. If every consumer can see where and when each item of food came from, there's no risk of receiving old or unsafe food. Consumers can also hold organizations accountable for large amounts of wasted food, as the numbers will be readily available. Being the first major shopping chain to bring this kind of transparency and accountability to your consumers would be a major competitive advantage. I mean, where would you rather shop? Somewhere that verifiably provides the freshest foods from the best locations with minimal waste, or somewhere that you just have to take their word for it? I know what my pick would be. Thanks for watching. Remember.
So this video might have gone through. So the Walmart has succeeded by providing the complete details of their food in their in the stock. So which has been received well received by the customers, and because of this, Walmart is now in the top. Always it is in the top. Now even more it is in the top because they have been introduced this blockchain also in the food products, and any consumer who buy the product will have a complete idea about when for example, fish example they given, when it has been taken from the sea, how long it has been stored in the cold garage, when it has been brought to the market. Imagine no one will try to purchase a thing which is very old. So that too in the food items we need it very fresh. So, but then how authentic it is. So the seller can say anything, but then whether it is true or not, whether it is really a fresh one or it is an old one stored in the cold garage. So many questions will come into mind when you consume a food. That too, when you consume a food. Nowadays we are very health conscious also. So to eradicate and to bring a complete picture, we can use this blockchain inside this food chain so that we can able to see how it has been improved the business perspective. Next, we have on the healthcare domain. So the personal health records, nowadays we are slowly moving to the healthcare records, and due to the COVID, we are slowly turning to the e-health. So the personal health records could be encoded and stored on the blockchain with a private key, which would grant access only to the specific individual. So these health records, also the health records means digitalized health records. We can also put it in the blockchain, and it is also mainly used in the insurance company. So nowadays insurance company are also using this blockchain. So whenever a person has insured his life and met with an accident, immediately the hospital will put the report in the blockchain, and so that the reports will not be tampered at any cost by the patient or by the doctors at the later stage. So even that HIPAA laws for insurance in US, they have been using this blockchain to give insurance for the patients. So whatever records with respect to the healthcare can also be put in the blockchain so that it cannot be mutable by any persons at any point of time. So one such example I have given a use cases is how we can use this blockchain to track the drug. Suppose imagine that you have a tablet, you want to make sure whether when it has been manufactured, when is the real expiry date, when is the forged expiry. Sometimes see, when you look at the back of a tablet, you will have a stamped one which says the expiry date. So that can be even erased, and you can have a duplicate expiry date also. So these are many questions that will come into your mind when you purchase a tablet from the medical shop. So how this blockchain help us in this drug storage that has been given here. So the manufacturer who manufactures drugs produce the drug makes with a unique code, and will produce in hash. The information is stored on the blockchain. Then the manufacturer will change the drugs to the wholesaler. Then the wholesaler verifies the origin of the product, where only the corresponding company has made this project or not. That will be easily verified by the wholesaler. The wholesaler now verify the origin of the product, and the transaction between the manager and the manufacturer and the wholesaler is added to the blockchain. Again, this transaction will be added to the blockchain. Again, the product will move from the wholesaler to the pharmacist. Again, the pharmacist verify the origin of the product. Okay, then the transaction between the wholesaler and the pharmacist is also added to the blockchain. Next, from the pharmacist, it will be delivered to the patient. The patient verify the origin of the product, whether this tablet has been manufactured only by that particular company, and whether it has expiry date and the content in the tablet, composition in the tablet as being correct or not. Everything the patient can able to verify
Voting is an essential tool for any democratic government.
I hope you can able to hear the audio.
Is the most important factor that makes a government for the people and by the people. Having said that, it's surprising we still haven't moved on from the traditional paper ballot system of voting. The paper ballot system has long been used by countries around the world. The concept is simple. You mark your vote on a piece of paper and put it in a ballot box. At the end of the election, the votes are counted and whoever gets the most votes is the winner. As simple as it may sound, there are a lot of issues with this system. The system cannot be automated and is extremely tedious. Between having to physically go to the venues where the ballot boxes are kept, to waiting in long lines, to counting and reporting votes by hand, the entire process is extremely time-consuming and extremely expensive. Malicious actors have many avenues to influence paper ballot elections, whether it's using intimidation tactics at the ballot boxes or just stuffing the boxes with fake votes. A highly motivated party or group could find a way to force the outcome they want. Lastly, maybe not one we think about most often, but it's impossible to keep track of or alter your vote. Are you sure it was counted? Was it thrown away? Did you make a mistake? Maybe a huge scandal erupted for your candidate later that day. The election isn't over, but you already voted. There's no way to change it now. So there are lots of disadvantages to a paper ballot system. To counter some of these, digital voting systems have been employed. But just like the paper system, current digital voting is too rudimentary and easily compromised. An attacker can infect specific machines with malware that alters votes, or even access the backend to move around and negate votes as they please. There may not be any obvious or clear examples of this happening yet, but it's a huge point of vulnerability that needs to be addressed. So how can the blockchain help? Let's look at an example. Follow My Vote is a company using blockchain technology and cryptography to bring voting into the 21st century. The goal is simple: make the election process as transparent as possible. Any potential voter can securely log in using a webcam and a government-issued ID. After they're done voting, they can use their voting ID to track their vote and check that it has been cast correctly. On top of that, they even give voters the ability to change their vote any number of times until the deadline. Elliptical curve cryptography, or ECC, is used to create these votes. ECC is a form of asymmetric cryptography that uses two keys, a public key and a private key, to encrypt and decrypt data. ECC is similar to what Bitcoin and Ethereum use for their cryptography. If you want to learn more about it, you should check out our Bitcoin course over on BlockGeeks. But how does Follow My Vote use this technology for voting? During voter registration, the voter creates two ECC key pairs. The voter reveals their identity to a verifier who certifies the first key pair. Once that's done, the voter registers their second key pair anonymously as belonging to their first pair. Then, the voter casts their virtual ballot and signs off on the vote with their private key. Once the vote is done, anyone can verify whether the signature is valid or not and make sure that none of the votes have been tampered with. All votes can be verified by using voters' public keys to see if they came from a legitimate actor. And that's how the blockchain can help create more secure, transparent, and cost-effective votes. Imagine being able to vote safely and securely from the comfort of your home. Imagine being able to vote on a multitude of candidates and issues without the government having to foot the bill for enormous election costs. The blockchain could help amplify the voices of the people by giving them an easier and better way to vote. Thanks for watching.
So this is how we can use this blockchain and e-voting. Last one we are going to discuss on music. So one of the key problem in music industry is that the owner of the music or the owner of the tune or the music will not able to get the proper revenue and proper recognition, because nowadays, because of this pirated issue, when you have, for example, imagine that I have a Sony music released on the Sony, so I can easily pirate it and I can even distribute to my friends. But at the end of the day, only if I buy from the Sony, the author of the music will get a revenue. So since I only brought from the Sony, I have distributed to 10 of my friends. So imagine that 10 of the friends who is able to enjoy that music, ultimately the owner of the music will not get anything because I have pirated things and I have been distributed. That's a real problem in the music industry. Because only if I buy from the Sony, Sony will pay to the composer of the song. If I only buy and 10 of them separate as a pirated version, at the end of the day, the composer of the music will not get any revenue. Obviously he will be in the loss. So this is one of the major issue in this music industry. So the ownership rights, the royalty distribution, and transparency is one of the major issue. So this digital nowadays what they started doing is that they're trying to release this music also, audio launch also. They do putting it in the blockchain. So what happens? Something is put in the blockchain. Definitely, anyone who want to listen that music, they have to also be part of the blockchain, and they cannot be able to pirate the things. So anything which is released on the blockchain. So the blockchain and the smart contract technology can circuit this problem by creating a comprehensive and accurate decentralized database of music rights. At the same time, Ledger can provide a transparent transmission of artist loyalties. So now, if there's something is released on the blockchain, we cannot able to pirate things over there. Whoever want to listen to the music, some definitely they have to buy by paying some amount of money to the composer of the song. So obviously, if you see the royalty for the composer of the song will be guaranteed if they release the music or the audio launch, it is done on the blockchain. They can make sure that whoever want to enjoy the music will definitely have to pay, and that way the revenue can be ensured. As I said, that's all the privacy. Every song will be unique ID and timestamps will be in it, and make the direct relations between the producer and consumer. So the consumer, whenever want to listen to the song, they have to pay something, and so that they can able to listen the song. So it is a revolutionary way by which the money can be earned by the musician. It's a long pending problem by the music industry that has been solved with the help of this Bitcoin blockchain. So now we have come to end of the session. So we have discussed about blockchain, and slowly we moved into the applications, like what are the issues in the current banking system, how Bitcoin solves, how the Bitcoin transaction take place, and we have discussed in detail about the Bitcoin future. That application in the banking industry of the blockchain has been discussed extensively. Rest of the applications we have sheet in a brief. Discussed in the brief is nothing but how we can apply the blockchain in the retail industry, IoT industry, music industry, and also in administration, governance administration. We have discussed in brief. And if you have any questions, these are the references which I have used for my presentation. If you have any questions, you can ask me. Now the session is open for question and answer shortly. Now, may I request the session to be taken over by the Lakshmi Madam. I will be here to answer the questions for another 5 to 10 minutes.
Yes, sir. Yes, participants, if you have any questions, please, you can. The session is open.
Sir, regard to you touched upon healthcare records and applying blockchain and consensus, all these ways. How better security aspects could be enforced, since it's a vital sign information about each individuals. And if you look at with respect to the killing kind of internal facemaker hijacking, there are a lot of things is happening in the e-world. How well this consensus mechanism, if suppose 2 or 3 intruders jointly updates the ledger, there may be a chances to access the vital information and even to attack a person in physiological world even. So can you suggest us any foolproof mechanism or kind of valid policy which is there in existence as a framework, sir?
So till now, if you see the blockchain, there has no been history recorded that the blockchain is hacked. You have to note this point very carefully. There is no history has been recorded till date that the blockchain is hacked. But application of the blockchain in some of the domain has some issue. That has to be properly implemented. If you want to implement this blockchain in some other application, that has to be implemented correctly. But till now, till date, as of my knowledge, there is no history that a blockchain is being hacked by the third party. But when you want to apply this blockchain in particular domain, that has to be implemented properly. I think that implementation should be taken utmost care when you want to deploy this blockchain in any of the application domain. So I think I have answered your question. The blockchain itself doesn't have any pitfalls. It cannot be hacked. Okay. So, but if you want to apply this blockchain in some of the application domain, that has to be properly implemented. There is still there is no history that a blockchain is being hacked.
Fine, sir. Fine, sir.
Any other questions, sir? Please? Yeah, please.
Hello, sir.
Yeah, please.
Sir, can we use the blockchain in the metamorphic cryptography application?
You can use, ma'am.
Yeah, that for that we have to go for a ledger or a smart contract, or that means hyperledger or smart contract.
Ma'am, actually, that you have to study the domain perfectly, then you have to apply that same.
Okay, yeah, thank you.
So before applying the blockchain, that's what I said again. Application of the blockchain in a particular domain has to be done carefully. Unless otherwise you know the domain, you cannot apply the blockchain arbitrarily in some domain. You have to study the domain thoroughly and you have to apply the blockchain in appropriate places so that you will have the complete benefits of the blockchain in your applications. First of all, you have to study the domain thoroughly. You should have the complete domain knowledge. Domain knowledge is very, very important. Only upon having the appropriate domain knowledge, you can able to apply the blockchain in that. If you have a very off-cooked knowledge in the domain and you want to apply the blockchain, that will not work out. Then definitely there will be pitfalls. And that pitfalls you can't put in the blockchain. I will say that pitfalls only can be blamed on the application side. I will not put it on the blockchain side. Okay. So before applying blockchain in any other domain, you should have a complete thorough understanding of the domain. Only upon having the complete understanding knowledge of the domain, then only you can put this blockchain, then only you can apply this blockchain in the appropriate place. Unless otherwise you cannot go for the application of the blockchain in any other domain. Any other questions? Any questions, please? So if there are no other questions, I'd like to thank Madam Dhanlakshmi, who was my contemporary PhD scholar, and our association is as long as more than a decade. And I used to call her Akka. She's very close to me, and we have grown together. That is what the beauty. And still, participants, if you have the questions, I have given my mail ID over there. I hope you all can able to view the mail ID, thiago@cutn.ac.in. And if you have any questions, you can also please mail me. I will be very happy to help in academic matters. So with this, I'd like to thank the organizers and all the coordinating teams, member and technical staff for arranging things very smoothly. Thank you so much for this meticulous arrangement. Thank you, ma'am.
Thank you, sir. It was a wonderful session. And as you said, it is more than a decade. And I am very happy to host you to the KCG portals. Thank you. It was a wonderful session, sir. I'm very proud that this has been taken very well by you. Thank you, sir.
Thank you, ma'am. Thank you so much.
Yeah.